Alright. So we've got this large area here. I'll start over here at the ports. So we don't have any joists running left to right yet. So we have to take this outer wall, this entire edge, all the way across, represents our baseline for our joist. So we could grab this, and all we want to do is figure out, sorry, I'm going to come over here, where a 2-foot increment is. And it falls at 18 feet. Okay, so match properties, turn this into a joist. Pull this over, and then let's array this 11 times. Yeah, there we go. So that gives us 11, and our distance, our span is about 9'7". We can do a 9-foot 10-inch span with a 2x6. So this will be 2x6s, and we can do 10-footers. So 11 2x6 10-foot long. Okay. Go into this room now. We are going to just offset this by 1.5 inches or so, and come all the way to this. Since these are flush beams, we don't go on top of them, we butt into the side of them. And let's array this that direction, and then array that this direction. So again, we've got a bunch of those. Now we're going to have a problem right here, because I know that this joist at the end is going to be either a 2x10 or a 2x12. I just know that based on the length. Well, you can't put a joist that close to the roof. Again, if we draw a side profile of a 121-inch wall, and we draw a 6 and 12 pitch, offset that 6 inches, erase that, let's give us our 12-inch overhang, erase that, go down 6 inches, and then over. Again, there's our box frame, here's our rafters shooting up. This is our sheetrock, and on our sheetrock we're going to have a bunch of, let's say they're 2x10, so 10 inches to there. And I know that they're not really 2x10, they're actually 1.5 by 9 1/4, but for purposes of this lesson, we're just going to say they're 2x10s. Well, the closest a 2x10 can actually get before hitting the rafter above it is about 20 inches. So this is currently shown at 5 inches, so there's no way anything, not even a 2x6 would fit that close. See, that's what it's looking like inside that large room. All these joists running this way. In fact, let's just figure this out real quick. 18-foot 1. So 18-foot 1, if you look at your span charts, we can do 2x10s, 12-inch on center, which means all of these have to be doubled, because we can't do 12-inch on center. We have to do, you know what, this is interesting. This is an interesting dynamic. This is one situation where we can actually do whatever we want, because this wall doesn't have any continuity to where the 2x4s are going to be 2 foot on center from this point, because it's mostly all headers. So that means there's going to be a couple of studs here, right? They're just going to put, what they're going to do is put a couple of studs here and a couple of studs here. Oh, I can't grab that. So we actually have, and then this whole entire wall here is a beam. I guess this wall here might be a problem. Yeah, let's just stick with the 24 on center. What I was going to say is we could do 16 on center, because we have the freedom to kind of do whatever we want on top of beams. But just for the sake of simplicity, let's just double all these up like this. And when we're putting that much weight, that's a lot of weight. Now you can understand why I want this one to be an engineered beam. Just because I'm not comfortable knowing what that sort of deflection would be. I'm still okay with this being a triple 2x12. So we're gonna, anyway, the point is we can't put a double here. The closest we could really get is about 20 inches. So where's 20 inches? about right there. So this one's okay, but that one's not. So what we have to do instead is, under these studs like this, do a whole row like this. And this is going to extend itself, I know, when we do this other side of the kitchen as well. Okay, so if this is a whole bunch of 2x6s, 2x6s can sit on a double 2x10. We don't have to make it a triple or anything like that. That's not necessary. So let's grab our notation here. And we have a total here of 24. 24. How do we have? Sorry. 24 2x10s by, oh goodness, I already forgot the span. It's 18 ones, so we have to do 20 foot. And then what I do is I take a text over here and I write doubled, because they're all doubled. You could say doubled, comma 24 inch on center. You don't have to put this 24 inches on center because everything is supposed to already be 24 on center, but it doesn't hurt just to remind them. Then we just come right here and this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 2x6 by 4 feet. And that really bears almost no weight at all on this, due to the fact that just by sitting on a 6-inch plate. And by the way, this is actually a 2x6 wall, but again, I've mentioned this before, the rafter does not sit back here on a 2x6 wall. It leaves this distance here too narrow when you do that, so they still will typically leave it back. So that's why we still draw, whenever we're doing plates, we always draw a 4-inch wall, because that's where it sits, right there. Just wanted to point that out. Alright, so we've got that done, we've got this done. I see we forgot this little spot here, so that's okay. We'll just come here and trim that off. And then just move this return air here. And add a couple of 2x6s on each end. Come on, there we go. And just put a little note in that one. Now, anything 3 or more, I'll go ahead and put this little arrow in it. So 3, 2x6 by 4 foot. That's done, that's done. So now we'll do right here. One thing that we can do is, since I know I'm going to be running my joist left and right here, we need a beam right here. It's a very small span. Does not have to be a big beam at all. Whoops. But since there will be some major roof loads, I guarantee you, the ridge of the roof is here. We're going to go ahead and still do it a triple. So this will be about a 6-foot triple 2x12. Okay. So let's go ahead and draw. And we come off this one. We know that these joists are accurately on 2-foot centers from here, right? So these are the ones that we want to copy when we create this over here. And what we'll probably do here is come to here. Now, if you go back to the floor plan, which we'll do here real quick, you'll see that this is a drop ceiling right here. It goes from, hold on, sorry. Jump in here. This whole thing here is a 9-foot ceiling. I may as well put that little note in here. Ceiling. 9 to 10. So go back to the frame. So this can be, and I kind of did this wrong. This really needs to say triple. 4 foot, 6 foot, to triple 2 by 12 by 6 foot dropped beam. It can be a drop beam because it's a lower ceiling right there. 10 foot triple 2 by 12. Draw them the same way. 6 foot. There we go. That's what we had before. Okay. And this right here can just run over that, like that. And I just remembered something. I forgot to point out a very important piece of the puzzle. There's actually, a change in the ceiling here from 10 up to 11. So this middle part here is taller, and I didn't notate that on the plan. So we see that it happens. Well, we'll just do this. We'll go to the 0 layer. We're in Joist. You'll see what I'm talking about. I'll just draw a line here. And it disappeared because joists are not on. Go back to frame. And it'll show up now. And at that point, right where that is, we need to put a beam. So we actually get to erase all of this. I should have been paying attention. We wouldn't have had to done this the wrong way to begin with. And this makes it even more important that this is an engineered beam, because we have a big beam here now as well, sitting on it, putting more weight on that. So that's probably going to be a pretty big beam that the engineer will figure out for us. So we're going to move this all over here. So instead of 24, we're actually going to have about, I don't know, 16 or so. Let's see. Yep, 16. And then this is this could be a triple. There's nothing wrong with that. This is 18 feet. You know what? No, that's too much. That's too big. So we'll do a 20-foot engineered flush beam, and then I'm going to say at 10 foot, and that just means the bottom of the beam is at 10 foot, because we have two different ceiling heights here. That makes it a little confusing. Then we'll copy one of these over here, and array this. That's 5 times. That engineered flush beam, this engineered flush beam, and then we can also just make a note here that this will be at 11-foot ceiling height. Any sort of little note like that to help make the framers realize there's something different going on here. Something's going on. We also know that there is going to be this down at that 10-foot level, so we just draw that there. that's going to be below these by 12 inches. This will be at the 10-foot ceiling height. This will be at 11. So all we got to put here is 8-foot 2 by 12, like that. And we'll also have to put in like a another one here. Do we have to put another one? Let's see. Nope, that's just that one. And this one will be another joist to hang sheetrock on. A 4-foot 2 by 12. And you might say, well, why do we need this 2 by 12? Well, because the difference in height is 12 inches. And they can make a 2 by 12 inches by just adding a 3/4 inch furring strip to it. So they'll still run these the whole length, but then they'll just put these little scabs up underneath to create that ceiling, which will end up looking like this when it's done. Okay. Alright, so then we need to notate these. And these are going to be, I'm pretty sure they're just going to be 2 by 6s. And the distance is 8'7". So we're going to have 10-foot 2 by 6s, and let's get this in the right spot. There are 9 of them. 9 2 by 6 10-footers. Okay, so that's all done. 11-foot ceiling, that looks right. That's all. Oh, we have to notate these. So we have two different fields here. There's this one. And just grab this text that says double and put it here because we want to just note that that is doubled. And this is 1, 2, 3, 4, 5, 6, 7. And our distance here is 9'8", which means we could go with the 2 by 6 because 2 by 6s can go 2 foot to 9'10". But I'm going to go do a 2 by 8 instead of a 2 by 6 because there's a good chance with the mechanical space here we're going to have some sort of AC units or storage or something right here, and I would rather put in a larger ceiling to make room for insulation and all that. So 1, 2, 3, 4, 5, 6, 7, 2 by 8s by 10 foot. Okay. And then the same is going to hold true here. I'm going to, even though a 2 by 6 would meet code, I want to go ahead and do a 2 by 8 just because mechanicals and catwalks and things up in the attic, right by the attic stairs, and this one can just be an 8-footer. Alright, so I'm going to, okay, so now we've got an attic stair. And so what we're going to do is grab this, because we know these are accurate, and figure out where a 2-foot, we're at 23.9, there's 24 feet, so 24 foot is that spot right there. And since we're putting an attic stair in it, we are going to double it, so double that one. And then take this one and go 24 inches over and double that one as well. So these two on the inside are our 2-foot spacings. Take that one again and now offset that 24, and this is our run again. We should be exactly 2-foot centers on this, which we are 22 feet there. And then array 12, 24, double this one. And just like over here where we can't have a 2 by 10 or anything too close to the roof, we can't do it here either. So we'll double that and figure out what that is. So put this here, put this here, and their attic access is too big. They don't actually make them that big. They'll fit between the rafters there. And we'll call that I just call it AC because we know that the AC layer shows up on both the floor plan and the joist plan. We have to create a double on the front side too. the front and back are the skinny ends. So copy this here, put this here, and there, and there. And then, again, we want to come off of this wall here, copying this on a 2-foot increment. Let's see, there's a 8 foot right there. Keep that copy straight. Yes, it did. Trim here. And then since this is hitting the rafters, we'll just break it off somewhere about like this. And I'll show you real quick what's going on there if it's not obvious. We have a wall here that's only 8 feet. 8'1". Okay. I'll do a 6-inch, but we'll go back to 4. And it's a 6 and 12 slope, so 12, 6 close, offset 6 inches. Offset, I think it's 21 on the front. I can't remember it. Let's just do 21. Doesn't really matter for this detail. 6 inch on the fascia. Again, there's our very simple box soffit. I'm going to just drive it up a little bit. And then our ceiling goes up to, in the garage, I think 9 feet, not 10. I think it's just 9. Let's see. No, I think it is 10. Yeah, it is 10, because if we look over here on the side of the where the garage is, which is right here, you can see we have a 10-foot wall, because the whole side is 10 feet. So as it slopes up to 121 inches, I think they were drawing this as a 9-foot ceiling. Let me think. Yeah, you know what? I'm going to change this to a 9-foot ceiling. Part of the reason is when you're crawling up this attic, you don't want it to hit your head on the roof, which is a very good possibility since we're only 6 feet away. That would mean that at this point right here, you're only 3 feet high. So we're going to go back to the floor plan and change this ceiling in the garage to a 9-foot ceiling. But I'm going to make a note that the wall is still a 10-foot wall. So 9-0 ceiling, 10-1 wall plate. And what that tells them is that they're going to have to build this at 9 feet and then build a little pony wall up to get to the 10-foot. But that'll give, I don't know what happened here. So that'll give a little bit more room to get up inside there, to get up into that attic space. So we'll go back to the framing plan. Alright, so now we're pull this down, and this is our point right here where our slope is. Move this over like that. And so this is rafters, because there's our rafters right there. And we know that for this span of 11'1", we're going to need 2x8 rafters. So if I were to draw an 8-inch by 2-inch rafter, you can see that the closest I can get is about there. So I could actually, let's see, that's too close. You see how this is actually beyond the point. This would hit the rafter. So I have to double it right here, which is where I had it before. And then what's going to happen is, if this is our rafter, we're going to have a little 2x6 stuck to the end of it. It's going to look like this. That's the shape of it. And so this rafter, this 2x6 rafter, extends into the roof, into the, this 2x6 joist extends into the roof about to here, which is why when we draw these, we just extend them a little bit, like that. That's how they look. Okay. And so that's done. So I'm going to go ahead and pause it and finish this all up and then show you the final result. Alright, so I've finished all the items. Again, since these are rafters, the undersides of rafters, we don't need to put any notes for joists there. The only exception being, I do know that they wanted to have a beam here. So let's go ahead and do that. Let's just change this to a beam, and it's going to be a dropped beam. So they wanted to have something that came down out of the ceiling, out of the roof. So we'll do a that's 16 feet long. So we'll do a 16-foot triple 2x12 dropped ridge beam. And then they're going to actually hang the lights from that. That's the only thing I'm going to add there. Everything else here is finished. The only thing that we would do at this point is don't move these, because these are here from the floor plan and they're just turned on in both layers. If you move them here, it'll move on the other one. I'm going to go ahead and turn on the rafters. Excuse me, the ridge layer. Here's our roof that we created earlier. And what I'm going to do is just change this to, well, just block it. Turn it onto the joists layer real quick, and we're going to block all of this. And what we're going to do is actually place this on top. 21 and 21 are my overhangs, with the exception of this wall here. We have to have a 12-inch overhang here because of our easement. We can't have an overhang in the easement. And now you can see how this point in the roof is going to need a brace here. This connection in the roof is going to sit on that wall, so we don't need anything there. This already has a double here, but what I'd like to do, this is going to be a pretty heavy point, is to add a floating beam from here to here that will be up above in the attic over all of this, that will actually help bear the weight of this. So we'll just grab this here, rotate it kind of like this, and set one end on the wall, not on the window but on the wall, and bring the other point over here. Let's even change the layer. Let's just do like that. Oh, I don't know why. It was in a block. There we go. And we're going to put a little note on it that says, and we measure the distance of it, and that's 19.6. So we're going to say a 20-foot triple 2x12 floating. And again, what that simply means is they will build this beam up above all the rest. We can, because we can do this because the roof is not sitting on this plate. I cannot put a floating beam over here like this, because this here is the plate wall. I don't have room to add a beam up above the joist, but I got plenty of room here and plenty of room here, so we're going to put a floating beam over that whole thing. We're also going to have, we're going to need to run purlin. If you remember from the roof plan, if we were to turn on the rafters layer and maybe the purlin layer, I don't remember if this job had a purlin. Yeah, it does. You can see that we have a whole bunch of rows of purlin. For the most part, they can figure this out in the field, but I like to just make sure that it's not going to be impossible for them to do it. So let's just turn those layers back off before we get into layered problems. Alright, so we'll be able to run purlin pretty easily. We may as well just put another floating beam. So you don't want to run your purlin on top, directly on top of your rafters. your joist, sorry, because it can cause your joists to sag inside the room. But a floating beam, if it sags, nobody cares because it's not actually connected to any sheetrock anywhere. And this one would be a 10-foot floating beam. Put it here. And when I do that, I like to move the text so that we don't have text overlaying each other. And we'll put another one here. This is going to be shorter. This will just be an 8-foot. We also have purlin that run the entire length of this, but we can't run any floating beams in this area. So what we'll do instead is just we'll jump these up to 2x10s, and that allows us now to come in and actually lay a purlin on top of these and support some of the weight of that wall. The other purlins, any other supports, will come off of this wall. So this point here can bear to this wall. This point can bear to either one of those walls. This point can bear to these walls. This point can bear to these walls, because again, this connection point is probably a good 6 or 8 feet above this, so it's easy to angle a beam over. There's a midpoint here though that it could sag, so we really should double up. Let's see, probably this one right here. And so when we do that, we change this to 14 items, 14 of them. So that's supported, this is supported, that's supported, that's supported, that's supported. Let's go ahead and move this up because I'm going to add a floating beam here. This. And it's going to be 10 feet long. And then I'm going to add another one here. And you might notice that these aren't straight or anything. That's okay, because the purlin up under the roof don't have to be straight either. They just have to be level. They don't make them be square to the frame or anything like that. So all we're doing is giving the framer some very nice spots to brace up to the underside of the roof. This one is 14 feet. And this ridge here is going to need some support. And earlier I said that we can't put a floating beam on a plate. The only exception is if it's a gable end. If you look at this gable end right here, we could run a beam anywhere up inside here all the way up to the ridge. So there is no problem with placing a floating beam in here. We don't want these to interfere with each other. And the distance of this one is probably 12 feet. Yeah. And one more. Let's put one in this room. So it's a whole wall of floating beams. Now, if we did not draw these, the framers would do them anyway. But the only reason it's nice to add them is that way the lumber company can go ahead and send out these extra 2x12s without for the guys having to ask for them. We cannot put a floating beam here because this is a roof plate. If I change this to a gable end, then we could run a floating beam here, but we cannot. So that's it. Then we erase this, and we are done with the joist plan.